Hello everyone, welcome to another video. In today's video, I will be discussing about a very important interview question that is about explaining a real world DevOps end-to-end CI/CD project. Okay, so I know a lot of people get stuck on this question, and a lot of my viewers also reached out to me to ask me if I can make a video specifically on this question. Okay, so whatever I'm going to tell you today is from a real world project that I have managed myself. Okay, so it's not a demo project that I'll be talking about. I'll be talking about all the different stages that were there in this project end to end, and how the deployment used to happen from dev to QA to prod. Okay, so all that will be shared in this project. All right, so let's get started. So in the interview, the question would be around the real world project. So it can be something like, explain the workflow of an end-to-end DevOps CI/CD project that you have managed. But this question has different versions to it, but it will be about a real world project that you have managed. Okay, so the interviewer wants to know the different stages or the exact workflow that you use in this project to confirm that yes, you have actually worked on a real world project. So how you're going to answer this type of question, I recommend that you start by talking about your company's business. For example, if your company builds critical alert systems for their customers, so you can mention that. Or if it is some other type of application, like you support a group of lawyers to do their job, you build applications for them, you can tell the interviewer. Okay, or it can be an e-commerce website, a travel portal, or it can be something else, but it is always good if you can start with this type of information. The interviewer will be really happy with it. Next, you have to tell them what framework you are using to build the application. Okay, so basically application programming language or the framework that you are using to build this application. So the project that I am talking about today is based on Java Spring Boot framework, but it can be other frameworks as well. It can be a Python application, it can be a Drupal based application, or it can be with some other programming language. Okay, so I think that's how you need to start your answer. Then you know that if we talk about one real world production grade application, it will have multiple tiers. Okay, so in this example, I'm taking the backend tier, which is built using Java Spring Boot framework. Okay, because for each tier you will have a different set of pipelines. Okay, for front end you will have a set of pipelines, for backend, for database, or if you have some other tiers as well, so the pipelines will be different. Okay, so you can tell them that I manage the backend part of this application. Okay, so this is how you can start your answer. Then in this example, I'm using the following tool stack and methodology. So what I'm going to use is in front of your screen right now. So this is like the a very high level application architecture. So we will be using a GitLab based repository. So GitLab is going to be our source code management tool. Okay, and it will have all your application source code files. It will have a Docker file which will be used to create a container image, and then you're going to use a Kubernetes Helm chart to deploy your application. So whatever image you have built using your Docker file and source code in your source code repo, that will be used to update your Helm chart with the updated container image, and then it will be pushed to an Amazon ECR repository. So this is going to be your container registry where you will be storing your container images plus your Helm chart. And then we'll be using ArgoCD as our deployment tool. Okay, so once you have your image and Helm chart pushed to this ECR repository, ArgoCD is going to use that to deploy to an EKS cluster in the development environment. Okay, so here I'm taking three environments: development, QA or test, and production. Okay, so the first deployment is going to happen in the dev cluster. Okay, so as you can see, whenever the developer is going to push any changes to the source code repository, the pipeline is going to run and it's going to start building the image, then updating the Helm chart, and then pushing the image and the Helm chart both to an ECR repository, and then this ArgoCD is going to detect that change in the ECR repository, that there's a new Helm chart that is available to be deployed to the EKS cluster in dev. Okay, so this is like a very high level overview of how the application, how this updated source code is going to be deployed to your EKS cluster. Okay, next, I hope this part is clear to you. If you have any doubts related to any of it, please reach out to me in the comment section. So for deploying our infrastructure, we utilize Terraform IAC that has been integrated within our CI/CD pipeline to create or modify infrastructure depending on the pipeline stage. Okay, so whatever work we are doing infrastructure wise, we'll be using Terraform. Okay, so a Terraform can very well integrate with your GitLab pipelines. So we can use GitLab templates to deploy our infrastructure with Terraform, and it can very well integrate with EKS clusters as well. Okay, I'll be talking about it at the end of this video in a little bit more details, but here I just want to give you the details of a real world DevOps CICD project stages and how the things are happening. So this is how the stages will look like. Okay, so you will have in total, if you see, 6 stages. So we will have 6 stages in our DevOps CI/CD pipeline in this project. Okay, and this is how it's going to look in a GitLab based platform. If you're using GitLab as your CI/CD platform, okay, not CI/CD platform but your CI platform, because the CD will be done in your ArgoCD tool. So this is how the stages are going to look like. Okay, so a platform check, validate, build, package, scan, deploy to dev. Okay, so let's talk about these stages in a little bit more detail. Okay, so as soon as the developer pushes the change to the source code management repository, what's going to happen? Okay, so just after the updated code is available in our source code management repository in GitLab, our CI/CD pipeline is going to trigger. Okay, then after triggering, what's going to happen? These are the different stages that will be used to deploy our changed code in the EKS cluster as an application pod using the built container image. Okay, so stage 1 is platform checks, which means that if I'm deploying it to dev, then my EKS cluster in the dev account should be up and running. The worker node should be in ready state. The critical system components like CoreDNS, kubeproxy, API server, etc. should be working. So stage 1 is going to be like a check on your cluster. So what I assume here is that you have already built your clusters in dev, QA, and production accounts. So what I mean is, here I'm using 3 AWS accounts, 1 for dev, 1 for QA, and 1 for production. Okay, this is how the things happen in real world. You won't have dev, QA, and prod in one single account. Okay, you will be using multiple AWS accounts, and those accounts will be interconnected to each other using various options. Okay, depending on your use case, you can use VPC peering. Okay, you can also use other ways as well, depending on the use case. Okay, I'll be talking about it at the end of the video. So the first pipeline is going to be deployed to our dev account. In the dev account, in the EKS cluster, which is already available. okay, which we have already created in. So the deployment is going to happen in that cluster. Okay, so stage 1 is going to be your platform checks. So if your EKS cluster is in healthy status, then this is going to be passed. This stage is going to be passed. So then you will move to the next stage, which is the validate stage, which is our stage 2. So validate means whatever Docker file you have available in your source code management repository, that is going to be validated for syntax, and all the manifest file for Kubernetes as well, those will be checked. If you are using some custom policies in your EKS clusters, that will be applied as well. And another thing is SNCC SAST. SNCC is a very popular security management tool, and SAST stands for Static Application Security Testing. So if you've heard about SonarQube in the past, okay, so SonarQube is another popular tool. So either you can use SonarQube or you can use some other tool like SNCC, which is going to perform a static application security testing on the source code, and it's going to give you the details of any code related vulnerabilities. Okay, so let's just read through. So stage 2, now after this platform check stage has passed, then stage 2 is going to be, this stage will test whether your Docker file is present in the repo and any Kubernetes based YAML manifest, including a Helm chart, if using one, are correct syntax wise. It can also test the Kubernetes policies. Okay, so if I talk about some of the policies that may be there, so you may be using a tool like Kyverno, if you have heard about it. Okay, so we may tell them that we are using a tool like Kyverno, which can restrict stuff like restrict creation of pods with elevated permissions. Okay, so this is like one policy that you can use inside your EKS cluster. So you can apply those policies using Kyverno tool. Okay, or does the pod satisfy resource limits or not? Okay, so this is just an example I'm giving here. There can be other policies as well, but I mean Kyverno is a very popular tool, and often in the real world you will be using some cluster policies. Okay, and you'll be using a tool to apply those within your clusters. So for any new request, these policies are checked for the request. Okay, then so this is done as part of stage 2. The next is going to be, now we have integrated the SNCC tool within our pipeline to perform this SAST, which is static application security testing on our code to identify code vulnerabilities. Okay, so this is going to be our stage 2. Okay, I just want to repeat here that this pipeline is triggered as soon as any developer has changed, or whenever a developer pushes any commits to this source code repository, this pipeline is going to be triggered. Okay, with these stages. Okay, so I'm talking about these stages after you have the commit in your source code repository. Okay, just to make it clear. So this is done. After that you have stage 3, which is your build artifact. So whatever code you have, you need to compile it, right? So you can use any compiler. You can use either Maven, okay, which I am using in this project, or you can use some other tool like Gradle as well. Okay, depends. Okay, what kind of project it is, and which is going to be a better tool for you. So it depends on your use case. But in my case, I was using Maven here. Okay, so a build artifact is the final packaged version of your application ready to be deployed. So if I talk about Java based application, you compile your source code files to create one, either a jar file or a var file, or it can be a zip file, or it can be a tar.gz file as well, or even it can be a Docker image depending on the use case. Okay, so you can use this Maven tool to build your artifact after stage 1 and stage 2 have passed. Okay, so you're going to get the artifact of your application that is to be deployed. Okay, it's going to be in these formats if you're using Java based application. Okay, so in the third stage of our CI/CD pipeline, once the code has passed code quality checks and unit tests, we initiate the build process. We use Maven or Gradle depending on the project to compile the source code, resolve dependencies, and generate a build artifact. Okay, typically a jar or a war file. Okay, .jar or .war file. This artifact becomes the core output of the build phase and is what we deploy to our dev, test, and production environments. Okay, I hope this is clear to you. So once you have passed these two stages, you're going to compile your code to create your main artifact that you're going to deploy for your application. Okay, so that artifact will be like a file in either of these formats. Okay, so let's talk about these tools a little bit more. So Maven and Gradle are tools that automate the process of building Java applications. It compiles your code, it resolves and download any external libraries your app needs called dependencies. So this is more related to the developers, but it is actually like a good to know information from a DevOps engineer point of view as well. Okay, so just to understand your application a little bit better, what actually happens when you are building your artifact. Okay, so these are the steps that actually happen. So you compile your code, you resolve and download any external libraries or dependencies that your app needs. Then you run some unit tests as well, and you package everything into a deployable file, which is called artifact, which I just spoke about. Okay, so this is going to be our stage 3. Then in stage 4, you're going to build your Docker file. So here I'm talking about containerized applications, of course. Okay, so after you have your artifact file, you can use your Docker file to build your Docker image or your container image, we can say. So stage 4 is going to be package, where you're going to build your Docker file, which means you're going to containerize the application. Then you're going to build your Helm chart. So what usually happens within a Helm chart, because I mean you'll be doing multiple deployments through the day, okay, throughout the day. So what you want is your Helm chart should have your updated container image, which will be created by the Docker file that you're using within your source code repository. Okay, so after you have built a Docker file, you're going to build your image, which is going to be updated within your Helm chart as well. Okay, so a build Docker file means containerizing the app, then add a meta to image. Okay, I think this step should have come before this build Helm chart, but anyways, so this is what the sequence is going to be. So you build your Docker file, then you add some meta to image. So the meaning of this meta is you are adding some additional information, or like tags to your image to identify the latest image that you have. Okay, so because you'll be creating multiple images, okay, whenever you are doing any new deployment, so you're going to be getting these multiple container images. So those images should be properly tagged so that you know which version you are deploying currently. So you're going to add some meta information to your images, which means that you're going to tag your Docker image. Okay, so in my case, I was using these two variables. I was using AWS ECR URI and the commit ID in GitLab. So whenever you do any commit in GitLab, you're going to get a new commit ID. Okay, so you can use that to tag your container image as well. Okay, this is again a very important question. Sometimes it is asked, how are you tagging your container images? So you can use this example. Okay, I was using AWS ECR URI, then colon, then commit ID to identify the different versions of my container image. Okay. Then next is going to be build your Helm chart. So after you have containerized the application using Docker file, you have tagged your image. Now it's time to build your Helm chart. Okay, build Helm chart means you have to update your Helm chart with the updated image. Okay, from the previous step, which is required for your Kubernetes deployment. In my case, I'm using AWS EKS cluster, but it can be other platforms as well. Okay, it can be some other like a cluster that you have built on your own manually, or if you have used a tool like Kops, it can be any example. But in my case, it was EKS cluster. Okay, so I'm going to build my Helm chart using the updated container image. Then after I have my image and my Helm chart, I'm going to push this new container image and my Helm chart to AWS ECR repository that I already have configured within my pipeline. Okay, so these are the 4 stages of, or you can say these are the 4 sub steps of this stage 4, which is package stage. Okay, then stage 5 is after you have your image and your Helm chart pushed to ECR, stage 5 is going to be scan your container image once again with another security vulnerabilities tool. Here I am again using Snyk tool. You can use other tools like Tenable, or you can use something like Trivi. Okay, and there are some other tools as well, but in my case I was using Snyk tool. So once the image is available in ECR, you have integrated this Snyk tool within your pipeline to scan for any vulnerabilities in your container image. So check if any of the software packages inside the image have known security issues. I'm talking about the different CVE IDs that you get for known vulnerabilities from the known vulnerabilities database. Okay, so when you use any tool, you get a few CVE IDs reported if there are any vulnerabilities in that particular container image, and then you can look for the solutions using this CVE ID online. Okay, and you can remediate the security vulnerabilities of your container image. Okay, so this work is going to be done by this Snyk tool. See if the images has any outdated libraries or risky dependencies. Report anything suspicious. Just like how antivirus software shows a list of threats, it's the same thing with the Snyk tool for your container image. It's going to show everything that is suspicious, that is a threat, that is a vulnerability that can be exploited. It's going to show the CVE IDs and stuff. Okay, this is going to be a stage 5. Then stage 6 is when you are actually promoting to dev cluster, which means that your image is going to be deployed to an EKS cluster now. Okay, so after stage 5, okay, once you have scanned your image, okay, after that what's going to happen, since the image is already available in ECR repository, okay, so the image is going to be deployed to EKS cluster via ArgoCD. Okay, so as I showed you earlier that I'm using ArgoCD to deploy the image, okay, via Helm chart. Okay, so what's going to be deployed? It's going to be a Helm chart with the updated container image into the EKS cluster using ArgoCD. Okay, this is what I was using. So let's go to stage 6 again. So what's going to happen? So how this deployment is going to happen to the dev cluster is also important to understand. So I'm going to create a config.yml file. It will have my Terraform version that I'm using. It will also have my Helm chart version that I'm using. Okay, so Helm chart version means whatever Helm chart was pushed to ECR, it will have that, and it will also have one Terraform version because I'm using Terraform to create this entire infrastructure. This entire script, this entire infrastructure is going to be scripted via Terraform files. Okay, so when you're promoting to dev cluster, what you're going to do is you're going to create a config.yml file with a Terraform version and the Helm chart version specified in it. And this is how the format is going to be. This is just like a custom format. Okay, it can be any format, but this was the format that I was using in my project. So service, the name of the service. Okay, and then you will specify the Helm chart version here from your ECR repository. Also, you will specify a Terraform version that you are using within this config.yml file. Okay, so how the structure is going to be, if you see, well, let me just come out of it. The structure of my source code repository will be something like, okay, it's going to take a few seconds to load. Okay, yeah, so if you see here, so my source code repository would look something like this. Okay, I'll be using a pom.xml file to get all the dependencies of the application. So since I'm using Java Spring Boot framework, so it can use this pom.xml file to specify all the dependencies. Then I'll have this src folder for source, where I will have these many files. Okay, and if you just scroll a little bit down, you will find one folder called dev. So in my source code repository, in my main root folder, I will have 3 folders for each environment. Okay, dev, qa and prod. In dev, I will have this config.yml file. Similarly, for qa and prod, I will have the same file, config.yml file, config.yml file. These files are specific to the environment only. Okay, so I can have custom configurations in these 3 files which are specific to the particular environment only. So this is how I was using different configurations to deploy to different environments. Okay, so let's go back here. So I'm going to create this config.yml file with this Terraform version and Helm chart version, which I just showed you. Okay, then I'm going to push the config to another GitLab repo. Okay, so this is like an optional thing. Okay, but in my case, I'm using just one repo to have this also. But if you want, you can keep this configuration in another GitLab repo. Okay, but in my case, I'm using just one repo. Okay, for all the things. As you can see, in my single repo, I have my source code files and everything. Okay, which is required for my application to run, and I also have these 3 folders configured. But if you want, you can keep this in a separate repo as well. Okay, depending on your choice. Okay, so this is completely optional. You don't have to create another GitLab repo. You can create the same repo to keep these config files for the different environments. Okay, then ArgoCD is going to detect a new Helm chart version. As I just mentioned, that ArgoCD works on the principle of GitOps. So it's going to detect the new Helm chart version, and it's going to start to deploy it to the dev cluster. Okay, then after the deployment has happened successfully, then you can also run some post deployment test also if deployed successfully. Okay, so if this deployment happens successfully, so you can check that on your ArgoCD UI platform. Okay, it's going to show you the status of your application, your pods, your deployments, your config maps, your stateful sets, your services, or any other resource that you've created as part of the application deployment. All that can be seen on the ArgoCD UI, and then it's going to run some post deployment test also to confirm if the application is healthy and functional as well at the same time. Okay, so all this can be checked on the ArgoCD UI. So this is how the deployment happens on the dev cluster. Okay, until this step. I hope this is clear to you how the things are happening. Okay, so we are getting this config.yml file for each environment. Then we are using the concept of GitOps, wherein this ArgoCD is going to detect the new Helm chart version and start to deploy to the dev cluster. Then if the deployment happens successfully, then you're going to run some post deployment tests. Okay, and then you can check the status of all the resources on the ArgoCD UI. Okay, now this is done. So up to dev cluster we have deployed. Okay, now how to do this same deployment in QA and prod, how the workflow would be. So that's interesting to understand here. So if I just scroll here, so now after your deployment has been done successfully in the dev cluster, if we need to deploy the same Helm chart from dev to QA environment, okay, we will create new configuration file for QA and update the version there. So what I was doing in this project is, I did not have this automation to deploy to dev to QA to prod automatically. We were using a manual process. Okay, but it is actually really good because you have like more control on the things. If you want, you can do it automatically also, but in my case I was using a manual process to deploy from dev to QA to prod. So what I was doing is, if I just scroll here, so you can see I have this another file called config.yml, but the format of the file is going to be same as the dev one. Okay, so if I want to deploy the version which I have deployed in dev, the same Helm chart I want to deploy to QA, all I have to do is I have to copy the version of the Helm chart from this config.yml file in the dev folder. I have to copy it to this config.yml file in the QA folder. Okay, and then just push my changes. Okay, so in this case, what's going to happen? The deployment is going to be triggered for the QA pipeline and not for the dev pipeline in this case. Okay, so if we need to deploy the dev Helm chart to QA environment, we will create a new configuration file for QA and update the version there. Okay, update the version means update the Helm chart version from dev to QA in that file. Okay, then this will trigger another pipeline for QA, which will take the dev Helm version and deploy to the AWS EKS cluster in QA AWS account. As I mentioned, I'm using 3 AWS accounts here, one for dev, one for QA, and one for prod. So the dev deployment is done. After that, I'm using the same Helm chart version, which I use in dev, to do the deployment in QA, for which I'll be using another config file, config.yml file, and it's going to trigger another pipeline for the QA deployment. Okay. And then similarly, once we are sure that the version is fine in dev and QA environments, we can do the same for prod also. So for prod also, I have this config.yml file. I will be updating this same version from QA to prod. So I'll be updating the version in this file, and then just I'm pushing the changes. It's going to trigger the production pipeline this time and not dev and QA pipeline. Okay. So a similar thing I've mentioned here. Similarly, to deploy the QA version to prod, we will have another file for prod configuration, and it will trigger a production pipeline. However, it will also have a manual approval stage to approve the deployment. Okay, so from QA to prod, I'm using manual approval as well. Okay, so within the pipeline, you will see another step, which will be like a manual approval, especially for production pipeline I'm talking about. So after you have pushed the changes in this config.yml file in prod folder, okay, the deployment is not going to happen. It's going to ask you for a manual approval. Once you approve it, only then the deployment is going to happen in the production. And this is how the things actually happen, because in production you have to be really careful. Whatever you're deploying, it's going to be deployed to the real-time customers or real-time users. So it has to be 100%. You have to be 100% sure of what you are deploying. Okay, so that is why we have this manual approval stage here. Okay, so after you manually approve the deployment from QA to prod, okay, so it's going to be deployed to the production to the real-time users this time. So this is how the deployment is happening from dev to QA to prod. Okay, I hope this entire concept and its entire workflow is clear to you. Okay, so I mean, whenever this question is asked, you will only have like, I think 3-4 minutes to answer this question. So you have to summarize all this and prepare yourself so that you can give a detailed answer in these 3-4 minutes, and the interview is able to understand the entire workflow of your project. Okay, so one more thing we can say, that we are using the concept of continuous delivery methodology and not continuous deployment in production, because we are using this manual approval stage, which means that we are using the concept of continuous delivery. If there was no manual approval, and whenever you make any changes to this prod config.yml file, if it was deploying to this prod environment automatically, then you can say that we were using the concept of continuous deployment. But since we have this manual approval stage, it is called continuous delivery. So we are using CICD, continuous integration and continuous delivery methodology in DevOps for this project. Okay, I hope this entire workflow was clear to you. Okay, if you have any doubts, you can always reach out to me in the comment section. Okay, so this was the entire project that I wanted to explain. Okay, but a few more things or a few more questions that you should know around this project, because the interviewer may still ask you some additional questions related to the project after you explain this to him. So what do you still need to learn so that you can answer questions on this project? How do you use GitLab templates to deploy infrastructure with Terraform in AWS EKS? Question number 1. Question number 2 is, how do we authenticate AWS ECR repositories with ArgoCD? How do we replicate AWS ECR repositories across accounts? Okay, because if you see, we just pushed this image to one account, which was a dev account, but we're using this same image in QA and production account also. So obviously your container images are being replicated from your dev account to QA and prod. So how that replication happens, you can search around that. Okay. So this is another question that you should know. Then this question number 4 is how to set up a single GitLab server to run pipelines across different AWS accounts. Okay, so this is like one scenario. So here in my case, I was using a single GitLab server, which I was using to deploy these different pipelines to different AWS accounts. So of course I had some sort of configuration between these 3 accounts. Okay, so I mean I was using some cross account roles to establish this type of work. Okay, but it is completely optional. You can have a different GitLab server in different AWS accounts also. It depends on your use case, but in my case I was using the single GitLab server, and it has it had a cross account functionality so that it can deploy to different AWS accounts. Okay, then question number 5 is how do you manage secrets in CI/CD pipelines? So of course when you're running this pipeline, you will have some secrets to deal with. So it's important to understand from interview point of view, how do you handle those secrets? So you can use many platforms. You can use AWS's secrets manager, which is really good, and it goes really well with your EKS clusters. Okay, but you can use some third-party application like HashiCorp Vault as well to do that. So this is like one of the important questions that you should prepare for the interview. Then how do you remediate security vulnerabilities found while running the pipeline? So when we use the SNCC tool to identify the vulnerabilities, we should know how to remediate those vulnerabilities as well. Then a last question is how do you manage the Terraform state file? So what I'll do is I will try to prepare one video on these questions as well. But this is like the information that you should also know. Apart from this project workflow, you should know the answers to these questions as well, so that you can prepare yourself really well for the interview. Okay, but I'll try my best to create the videos around these questions as well. Alright guys, that's all I wanted to cover in this video. I hope this video was useful to you. If it was, I request you to please hit the like button. Please subscribe to my channel and please share this video with your friends and colleagues. Alright guys, that's all for this one, and I'm going to see you in the next one.